We have an arithmetic progression where Sn represents the sum of the first n terms. Also, it's given that the ratio of the sum of the two n terms to that of the sum of the n terms has a value of 3. Using this information, we need to obtain the value of the ratio of the sum of 3n terms to that of sum of n terms. So let's begin. First, we will be considering supposing the first term of the arithmetic progression. Let it be denoted by the letter a in lower case, and our common difference will be denoted by the letter d in lower case. We know that the sum to n terms, the general formula Sn, that's given by n over 2 multiplied to 2 times a, the first term, plus n minus 1 times the common difference d. Now, using this fact, so let's come back to our ratio. It's given here that the ratio of sum up to the two n terms divided by sum up to the n terms, that's 3. So sum up to the two n terms, using the same formula, we'll have 2n over 2 multiplied to 2a plus 2n minus 1 times the common difference d, whole divided by the sum of the n terms. So up to n terms, we have n over 2 multiplied to 2a plus n minus 1 times the common difference d. So this has a value of 3. Now, we can cancel out n over 2 from both the numerator and the denominator. So we have, and we can, okay, let's write it down first. So we have 2 times 2a plus 2n minus 1 times d, whole divided by 2a plus n minus 1 times d. This will be equals to 3. Then I'll multiply 2 with 2a plus 2n minus 1 times d. With this, we're going to give us 4a plus, so we'll multiply 2 to 2n minus 1. So we have 4n minus 2 multiplied to d, and we'll take the denominator and cross multiply it with 3. That gives us 6a plus 3n minus 3 times d. Now we have 4a plus 4nd minus 2d equals to 6a plus 3nd minus 3d. So we can transpose all these three terms from the left, right hand side to the left hand side. So we will have 4a minus 6a plus 4nd minus 3nd. Then a negative 2d plus 3d, this is equals to 0. So the 4a minus 6a, that's negative 2a. 4nd plus minus 3nd will be positive nd. Then we have negative 2d plus 3d, so that will be simply d. This is equals to 0. Or we have n plus 1 times d, so we're taking d as the common factor from the second and the third term, and we'll transpose the first term, which is negative 2a, to the right hand side to get 2a. So this is a relation that we have obtained. We'll keep it aside for the time being. Let's label this as equation number 1. Now, our task is to find out the ratio of the sum up to the 3n terms to that of the sum of the n terms. So we know that this is going to be equals to 3n over 2 whole multiplied to 2a plus 3n minus 1 times the common difference d, divided by, we have n over 2 sum to the n terms to multiply to 2a plus n minus 1 times the common difference d. So here n over 2 and n over 2 goes away, so we have 3 multiplied to 2a. Now in place of 2a, we can use equation number 1 to replace it with n plus 1 times the common difference d. 3n minus 1 times the common difference d, divided by, so in the denominator we have 2a, so this 2a can be also replaced with n plus 1 times the common difference d plus n minus 1 times the common difference d. Fine. Now we can take, so this is the ratio s 3n over sn. This will be equals to 3 times, so we can take n plus d as the common factor, so we have 3d, so 3d will be multiplied to n plus 1 plus 3n minus 1 whole divided by, if we take d as the common factor, we have n plus 1 plus n minus 1. Fine. So this will be, so the and d goes away, we have 3 multiplied to, so 3n plus n, that will be 4n, so 1 and 1 goes away. And in the denominator, we have positive 1, negative 1 going away, n plus n will be 2n. So this is going to give us 12n divided by 2n, which is simply 6. Therefore, our final value, that means the ratio as sum up to the 3n terms to that of the sum of n terms, this value is 6:1.